Here is a bicycle hub, a free hub made by JK Industries. This is where their initials are stamped into the flange in the hub, and this is how the company website looks like. The website is not especially interactive. You can click on this and then this happens, and then you can click on anything you like. Nothing happens whatsoever, but anyhow, they make hubs and they are based out of India, hereabouts. So in this video, I'm gonna take apart this failed hub. The hub itself actually looks fine as is. The bearing has been removed from this space here, the axle has been removed, and what's actually failed is the bearing inside the freewheel here. It's really catchy and jittery, and this is not how it should roll and not how it should sound like. So let's take it apart. So on the workbench here, I'm going to be using this Shimano hub remover tool-ish, but not made by Shimano. It does have a hole in there and two teeth that engage with this lock ring inside there, and then you just have to find an appropriately sized wrench that fits on it. But in order for these two teeth stay inside, they need to be kind of held in place so they don't do this. You can see it's kind of rising out of its space. So that's where this skewer comes in handy. It goes in from this side, and with a wing nut, the tool is held in place exactly where it should be. It doesn't jump out of those notches there. Just mount it in the vise and it's good to go for disassembly. This lock ring is reverse threaded, so it's gonna tighten this way and will loosen this way. So let's take a look at what lives inside this hub. And there we go. Ouch. Maybe even something broken there. That doesn't bode well. And it doesn't look like there's enough lubricant in this thing at all, because it's not holding the bearing balls tightly or in any way. Ring gets into this type of open bearing. Let's check out the raceway here. Well, it's got a wear line on it, all right. I'm gonna have a closer look for pitting. Let's see what else here. Yeah, this doesn't look good. This ring here failed rather catastrophically. So let's look at the components, all of them that I could dig out from inside the hub, and look at the carnage. Let's start with what failed. Obviously, this thin washer here completely disintegrated, and this is how an intact looks like, and this one is just garbage. I can't rebuild a hub without that washer, so that's not working. Now the broken bit is right here. I'm gonna try to look at it in a sec, but this is what it broke off. But before we look at it, this is how an intact one looks like. This is an engagement pawl, and I'm trying not to leave pliers marks on it to make it look worse than it actually is. So this is how the piece looks like when it's intact, and it's got some unique features on it. One, is it's a weird design that part of it would be so thin here and pointed so that it breaks off there like that. But even this intact one is bearing some battle scars. So if you look at this corner right here, it looks like it's been gouged into with a bandsaw blade or a file. Don't look at my nails and the hideous manicure situation here. So this corner on this engagement pole is not looking good. Those marks shouldn't be there. This normal manufacturing striations or marks can be seen on the side of this pole or here on the side, but that corner is not looking okay. This corner here also looks like it's been chewed up. Just the corner there is rounded. Now rounded could be fine, but this is rounded ugly, unevenly, as if it was rounded with a file that's been held by an apprentice or something like that. So it's not looking good. This piece should be intact. Now, how this component works on the hub is something like this. It kind of sits like so, and in normal operation it's springing up like so, held in place by this spring steel, completely intact retaining ring that I'm going to try to put on quickly. Oh, there we go. So this spring retaining ring is in place and it's holding it down, so it pitches up in normal operation and makes this ratcheting sound, yes, as this engagement pole is being dragged around in a circle there. So this is the intact side, and the other one obviously broke off, and so this cannot be rebuilt. It's you can see missing this small component on it, and the surface is compromised here that would hold this down. Now you can see on the surface of it where it broke off that it underwent a brittle failure. This broken surface here appears to be coarse and granular like this. There was a sudden failure at one point, so this engagement pole has not been properly manufactured. So I tucked it underneath this spring retaining ring. It still somewhat functions, and now both of them will be ratcheting if it stays in place. No, it doesn't. Yeah, so it doesn't want to really stay in place for ratcheting. Let's take a look at the broken bit here. Its corner is also, it's different from the previous one, but similarly gouged out at that corner. And it's interestingly not rounded off at this corner where the other one is rounded off. It got mangled at the opposite corner somehow, probably because it moved around inside between the bearing balls. And let's look at the fracture surface. The fracture surface again is grainy, but you can see the shiny dulled spots on it. It's been in contact with rotating bearing balls that wore down the high points on the fractured surface, so that's what's causing those shiny spots on it. All right, so it hasn't been properly made. It's too brittle. It should be annealed, that's a heat treatment. It should be softened just a little bit after hardening it, so this kind of brittle failure doesn't happen inside the hub. It makes the whole hub garbage. So this was made by JK Hubs, and it's been installed in a WTB SX19 wheel, whose rim is this WTB SX19. So the rim has failed. That's a separate video. I'll include a link in this video's description box below. So the rim failed, the hub failed. It could be a WTB wheel, it could be a JK hubs wheel. Anybody who wants to claim ownership over it, go for it. Both components failed, the hub and the rim. It was on a bicycle that was sold by Norco. Now, Norco is not a major manufacturer, and either they have express knowledge of the substandard metallurgical treatment of critical components at JK and at WTB, because again, hub and rim both failed. So, or they knowingly purchased hubs that are known to be substandard like this, and rims that are known to be defective or under-engineered. So there you have it. So that's what you get from a lesser manufacturer in some cases, like Norco. You get a substandard hub and a substandard rim, both fail, and now you need a new wheel. So on top of the cost of the bicycle, you also have the cost of this. So along with broken free hub pawls floating somewhere in the system, let's see what else failed here on this JK Industries masterpiece. So this surface here is where the bearing balls run, and when you look at it from here, it looks like, hey, everything is fine, but no. You see the surfaces, how they look rippled and dimply, slightly dimply, like it's got cellulitis or something. Right where the bearing balls run, yeah, so this surface is pitted. It's a failed surface here. It's not worth doing anything with it. JK Industries apparently produced a surface there that isn't hard enough, or after 10,000 kilometers it wasn't sealed well enough properly to keep the rain out of, or whatever happened here with corrosion. So, but this is not how a properly hardened surface looks like. So some parts of it appear to be better, but no, it's pretty evenly dimpled in tiny little, look at where the light is glistening right there. So small sections of deeper, there's a dimple right there underneath the light right there. Yeah, that shouldn't be there. Okay, and the same elsewhere where light is glistening, like what are those dimple holes there? Okay, so, and this is a failed bearing raceway. The bearing balls, all of them are presumably all garbage likewise. The bearing surface is not any better either on, so this is the lock ring that was removed with this tool, brilliant tool by the way. So this lock ring surface here is also looking, there's a dimple right there under my nail, so that shouldn't be there. Okay, so that side goes for the whole length. It's fares a little better, but there are dimple marks there, 2 huge dimple marks right there. All right, so this is garbage right away. Now, if I had to rebuild this hub, it could still be, put some grease on it, put the bearing balls back on. Hey, it's gonna roll. No doubt, it is going to roll. And with only one engagement pawl plus another one kind of somewhat in, it could be somehow very slowly and carefully put back together, and it can be made to work. There's no doubt about that. But this is not how high quality components perform and wear, okay? This is not the metallurgical treatment that these have gone under. No, that's not how, this is not how quality components look like. I can't really rebuild the hub because the thickness of this is missing from it and would need another thin washer like this. So maybe I can reuse this thin washer in another JK hub that failed, I don't know. And this washer here also came out of this. It's been damaged inside the hub. I didn't damage it with my tools. You can see it's damaged there, and so that's also no go. All right, so let's sum it up. The hub has been manufactured in a substandard way. The rim that this hub was part of was designed wrong. And lastly, I want to tell you why this washer failed is because this ring here was likely over tightened by some in the factory where this whole thing was manufactured, over tightened to the point that the resultant friction completely wore away this thin washer and gouged it out initially and then wore it away into fine metal dust particles, which are everywhere on the reg here and on this other reg that I started with. So the rim has a bad design. The hub has a substandard manufacturing and a substandard assembly. So that's what you get from manufacturers like Norco who go with these budget wheels.